So problem number one, out of 4.3% change in differences. Says the table, and I underlined table because that's where I got the numbers from, a table. Shows how crime has been decreasing in a certain country. What is the total change in murders from 1995 to 2012? So the way you would find the total change is by taking the new value minus the old value. So that your new year is 2012, old value is 1995. So in 2012, they had the value of 14,066. In 1995, they had the value of 20,079. So subtract those, you have negative 6,013, and it should be negative because remember we're talking about decreasing. Decreasing in a certain country, so our value would be negative. All right, next one. What is, excuse me, what was the percent change of murders from 1995 to 2012? So to find a percent change, you would take that value that we just found, which is negative 6,013, and divide it by the original amount. So our original was at 20,079. And divide that out. Negative 0.299 converted to a percentage by multiplying it by 100. And that's negative 29.9%.
Can you keep that up for 1 second?
Not a problem. All right, are we good to go? Let me know.
Okay.
All right, somebody said, oh, okay, good to go. All right, cool. All right, so the next one, I didn't do C because it says which crime rate experienced the largest percent change from 95 to 2012. And so you will just repeat the processes for A, B. They have 4 different categories. They had a violent crime rate, murder crime rate, property crime rate. I think the other one was car theft, motor vehicle theft rate. So you just take each one of those rates and repeat the same process from A to B. You subtract the new and the old values from 2012 to 1995, then divide by the original value. And then whichever one had the largest percentage would be the actual answer. So, all right. Questions on number 1 before we look at number 4? All right, so number 4, find the absolute change and the percentage change in the following case. The average sale of a house decreased from $322,000 in February 2008 to $166,000 in February 2013. So we want to find absolute change and percent change. So very similar to what we just did, the absolute change will be a new minus your original. So the 166,000 minus your 322,000 will be 156,000, negative 156,000. And always, if I scroll up too fast, let me know. Of course, I can't see anyone, so I don't know if you're done writing or not. So your percent change will be the absolute change of negative 156,000 over 322,000 times 100%. So that'll be 48.4. All right, any questions? All right, so number 6, the gestation period of bears is 220 days. Not is 220 days. The gestation period of bears, which is 220 days, is blank percent longer than the gestation period of sheep, which is 145 days. All right. So the way we will find our relative difference is that we will take the absolute difference, place it over our reference value. So this is the same process, just the terminology is a little different because we're not comparing bears. The bears is not like we're having a bear original amount of days, then it increases to 235 or it decreases down to 132 or something like that. So we're comparing bears to sheep and their gestation periods. So it's changing the terminology, but the process is still the same. So we're going to do our compared value minus the reference value over the reference value. Remember, we did the new minus the original over the original. So the reference value in this case is the 145 days because we're saying that bears is going to be a percentage longer, than the period of the sheep. So we're comparing the bears to the sheep. So your bear will be your compare, your sheep will be your reference value. And so that would be your 220 minus 145 over 145. And multiply that by 100, and that'll give you 51.7%.
Excuse me, can you scroll up some, please?
Mm-hmm.
Thank you.
Not a problem. All right, questions? Any questions? Anything else before we go to the next one? All right. That was just something I was messing with another student. They asked me a question. A lot of these problems in here are either conceptual, they're asking you a question versus calculation, or they're very similar to what we just did. So try these problems out of 4, 3. Once again, if you have questions, make sure you ask them. And we'll go from there. All right, so let's look at 4-4, some problems in 4-4. So let me get the backstory on this one, because I didn't write that, because it was a lot. All right, so it says going into the quarterfinals, a hockey tournament, of a hockey tournament, a certain team lead the league in power play conversions. A power play occurs when one team gets a penalty so that they lose a player. This results in a 5-on-4 situation. Converting on a power play means that the team with the player advantage scores a goal in the time allotted. So the team has 165 power plays. Yep, team had 165 power play opportunities and converted on 57 of them. What was their conversion rate? So all you would do is take 57 and place it over the 165, multiply by 100%, and you get 34.5%. All right. Next, their opponents had 125 power play opportunities, and the team killed 109 of them. That means the opponent failed to score. What was the opponent's power play conversion rate? All right. So first thing you want to know is how many times they did score. So you take the 125 minus the 109, because remember 109 is how many times they didn't score. So there'll be 16 scores. Then you take the 16 and place it over the 125, the number of opportunities that they had altogether. And that'll be 12.8%. All right, questions? C, what was the total difference between the team's conversion rate and their opponent's conversion rate? So you just subtract the two numbers, the two percentages we just calculated. So 34.5% minus 12.8%. That gave us 21.7%. And what was the percentage difference between the two? So if you're comparing the team's rate to the opponent's rate, you take that 21.7 and place it over to 12.8. The 12.8 was the opponent's score rate. And you can say that the team scored 169.5% more than the opponent. So that's why you put the opponent in the denominator. All right, questions? Any questions? All right. Let's look at number 2. Compute the total change in 65 years and over group from 2015 to 2060. So, of course, there was a chart. These values didn't come out of nowhere. 2015, the 65 and over group had, let's see, what were they doing anyway? Let me go to the backstory. Quarterfinals. Shows projected, the population. Okay. So this is a projected population of this a certain demographic. So the demographic they're asking us about 65 years and over group. So we're talking about 12.4% versus 19.3%. Yeah, percentage points. Okay. But yeah, so those values are in the chart. So we would subtract the 19.3 with a 12.43 from the 19.3, which would give us 6.87. So that would be the change in percentage points, 6.87. Then B asked us to compute the percentage change or the percent change. So we take that difference that we found in the first problem, place it over the original amount, which is 12.43, which is a similar process as to what we've done, even in 4.3. Subtract your data values, then divide by the original amount. All right. Multiply that by 100, you get 55.7.27. right. So let's look at 3. So the population of city A is 36% less than the population of city B. So city A's population is blank percent of city B's. All right, so keywords here. If it's more than, we will be looking at 100 plus P percent. If it's less than, we're looking at 100 minus P percent. So the keywords here for us is less than. So we do 100 minus 36%, which is 64%. So you take that, put it in that blank. And so city A's population is 64% of B's population. All right. Questions on that? Let's see, I got another one. Yeah, I thought so. All right. So here, the annual interest rate for Jack's savings account increased from 3.7% to 5.4%. First question, describe the change as an absolute change. All right, so this is very similar to what we've done up to this point. Take your new value minus your reference value or your original value. 5.4 minus 3.7 is 1.7. So that's your absolute change. Describe in terms of percentage. So you take your change, your absolute change, and divide it by the original amount. 1.7 divided by 3.7, 45.9%. Any questions? Any questions? All right. Let's look at the next one. The sales tax in the city is 4.5%. How much tax is charged on a purchase of $56 and what is the total cost? All right, so sales tax, something you may want to calculate if you were in Walmart or something like that. You have your cost of your merchandise times the actual tax rate, whether it be of the city or state. And you multiply that, convert it to a decimal, multiply it, times the cost of the merchandise. That would be $2.52 in this case. Then to find the total cost, take your cost of merchandise and add the sales tax to it. And in this case, that'll be 58.52. All right, questions? Any questions? All right. All right, this one, 7 and 8 are very similar. So I think this was number 8, but 7 and 8 was similar. That's why I wrote 7/8 up there. So I just did one of them. Diners frequently add a 15% tip when charging a meal to a credit card. What is the cost of the meal without tip? If the total amount charged is $63.25. All right, so we have an original amount plus the increase is going to be equal to the new amount. So your original amount is 100%. Your increase is 15% of your original amount. So that means your new amount is going to be 115%. Okay, you have an original amount, which was 100% of your purchase. 15% of your purchase was the tax. I mean, not your tax, tip. So your whole amount would be that 100% plus the 15%. So in problem number 7, it's going to be a very similar situation where you're adding 1 to your 100 to your rate, your percentage. So what I did from there said that that 63.25 represents that new amount. So that means 63.25 or $63.25 is 115% of what amount? The original amount is what we do not know. We just know that 63.25 is 100% of that original amount. So we talked about last class how we can set it up as an equation if we can see this relationship, wherein is your equal sign, 115%. We'll convert that to a decimal to 1.15 of is multiplication, and your what is your variable. So from there, we can divide both sides by 1.15, and our original amount is 55. Any questions? And was looking at doing another one, but I don't think I did it after this one either. No. I was looking at number 9, which is very similar to what we've done up to this point. Subtract your 2 data values, then divide by the original, and multiply by 100. So all of them are pretty much similar to what we've done. When you're subtracting your data values, finding that difference, finding that change, then dividing by the reference value or the original amount. So like I said, 9 is just like that. So questions on anything I've written? Any questions? All right. Questions on how we're going to handle class next week. So once again, just in case you came in late, I have posted your review. It is in your homework. So it's under your homework tab. It's set up as a homework, so you can do it unlimited amount of tries if you want. If you want to get that practice in. Next class, if there's something you could not figure out over the weekend, next class, Monday, will be set aside for you to ask whatever questions you want to ask. I will not do anything new. I will not bring anything to the table, just answering questions, seeing if I can help you guys out. Then on Wednesday, we're actually going to take the test. So you come with your video cameras open so that I can see you, some type of legit ID, and which validates who you are. And then from there, I will we'll proctor the test. We'll do the test. There's like 30 problems up there. I left it at 30 because a lot of the problems I chose, because I was picking problems at random throughout the homeworks, but a lot of problems I chose didn't call for any calculation. And my math lab said that it would be around 60 minutes worth of work at the most. And so, since we have an hour and a half to work with, that should be good for you guys. Also, try not to stress too much. I probably will create a makeup opportunity if you were to not do as well as you like. But the first thing you want to do is focus on the task at hand, and that is actually taking the test. So we can talk about other options later. But questions, concerns, comments on anything before we look to close out? Okay, everybody good, everybody straight. All right. So if you have any questions, never hesitate to get in contact with me. Outside of that, you guys have a great weekend and be safe. See you on Monday. Maybe we'll talk about it as far as the makeup is concerned, but we're not talking about that until after we take the test. All right. Oh, let me stop the recording.